Okay.
All right, I was just going to talk to you a little bit about going outside to Barker Lake and Salt Creek for the project. First and foremost, I'd like to make sure that you're representing your family, you're representing yourself, and you're representing your school when you go out there. So, Mr. Mott and I would like to see you be on your best behavior while you're out there. And just remember, you're also representing us while we're out there. So to get started here, I just want to go through a couple of the chemicals that are in here, how to use them, and what you'll need to do to be successful when you go outside. First things first, you'll either have this application available to you online, or you can print this out. These are the directions for the procedure, so make sure you got those while you're going outside. That would be very helpful. When you first open up your chemical test kit, when you get outside to your locations, and we'll show you all those locations, make sure your goggles then go on so that you're safe, because there are some chemicals out there. You open up your test kit. There's going to be several things that I want to make you aware of. There's going to be three main chemicals. How do you know which chemical is which? They have 1s, 2s, and 3s on. So for instance, I'm looking at this one. This has a 1 on it. This is your chemical number 1. This will be your dissolved oxygen chemical 2. And your third one is a little bit different in how it looks. It's called a powder pillow, because it kind of looks like a pillow that Mr. Mott would sleep on, little itty bitty, because he's got a little itty bitty head. Nice kid, though. Anyway, just kidding. So we'll put that in there. And this will be your dissolved oxygen bottle with your round bottom stopper in there. So when you go get your, I'm going to run to the sink real quick and get a water sample so you can see what this looks like. I'll be right back. All right, I've got my water sample right here. I got my stopper. It says to thrust it in there so you don't get any air bubbles. You don't got to get crazy with it. They are expensive. So, that got a little crazy right there. But you can see now I don't have any air bubbles in my sample. You'll also be going out to the creek with a milk jug, a water bottle, which you should fill with water so that you can rinse out your glassware. And you don't want to put it in the lake, in the stream. You want all chemicals and wrappers to go in this milk jug. That's what it's there for. And lastly is the ladle to scoop up the lake water so that you're safe there. I don't want you going in there and scooping it up with your hand or something else. So if you got any extra water, you can put the stopper, dump it in there, and now I've got my stopper set. So I'm going to go ahead and add the chemical kits. I know you can't see my head here. It says in the directions to add chemicals 1 and 2. So you're going to take those. The scissors are there for you to open up those packets. So I'm going to go ahead and cut open those packets, all right, and I'm going to go ahead and dump those chemicals in. I don't know how well you can see that there from your vantage point, but you're going to go ahead as best you can, add those in there, get as much of them as you can out. I've got a little residue. I'm without the advantage of a lab partner there. So what am I going to do with those wrappers? Go ahead and pause it, ask your neighbor. Ask yourself, if you're watching this alone, what are you going to do with the wrappers while you're out at the creek? All right, hopefully you come up with the solution that you're going to take the wrappers, you're going to put them into the milk jug bucket over there, so you're leaving the environment in a better position than it was. Also, if you find any wrappers out there, candy wrappers from students or whatever, put them in this milk jug here as well. So now it says to shake vigorously, so I'll put my stopper on, okay, and shaking vigorously, you can still see, because I had some chemical residue along the side, I still get a little bit of chemical coming off to the side. So be careful that you're not shaking it near your lab partner and getting it all over them. So you're going to shake it vigorously. I think it says about a minute. And it says a flocculent precipitate will form. Most of you do not know what the flock I was talking about. So I'll kind of give you a visual so you can see what the flock is. So I'll come on in there, and you can see, basically that orangish brown solid. That's going to eventually get a little more dense than your liquid in there, and it's going to start to kind of precipitate downwards. As soon as that gets down below the white line, that's when you're ready to go. So you can see that flock starting to form at the top. It eventually will start to settle towards the bottom. And I'll show you that in a second here. So I'll shake a little bit longer. I don't know if I did a full minute. All right, and then it says allow it to stand. So I'll let it stand there. All right. Leaving the upper half sample clear. So just look for the white line to see when it settles below there. Now you're going to go to your powder pillows. So I'll just momentarily remove this here. Get one of these ready to go. Screw this on there so hopefully you can see that in your window screen there. The powder pillows are a little bit tough to, especially if you got meaty fingers to use the scissors, but you're going to try to get into one of those there. Some of you have toenail clippers. Those might work a little bit better. Once you get that, I know it's a pain in the butt, but go back, see where this landed, pick it up, put it in there. Get your sample. Looks like my flock didn't settle as much as I would have liked it to, but I'm going to go ahead and add, due to time constraints here, add my third powder pillow here. Carefully insert the stopper again and shake to mix again. And it says a yellow color will persist. So I'm going to go ahead and shake vigorously. And you can start to see that it is turning a yellowish brown. A little bit more yellow there. That's what we're looking for. It says the flock will dissolve. So now the flock should be starting to be clearing up. You should get almost a yellow urine color. Okay. You can see most of the flock is gone. Okay. So I'll let that set right there. Now we're ready to fill this measuring tube. This is the measuring tube that you'll be using. I'll get down a little bit so you can see me. So when you're ready to fill this, some of you will have a little squeezy dropper, a little eyedropper if you will. That might be easier for you to get your sample and put it into the measuring tube. Others, you can be real careful with pouring it. But if you're out there, if you're gonna pour it, if you don't have an eyedropper, do it over your plastic milk jug. But otherwise, if not, ask Mr. Mott or Mr. Scott for, thank you Mr. Mott, for an eyedropper. That can be very helpful. So you get your measuring tube filled. Oops. You want to fill it all the way. So now I've seen a couple of students, they'll go ahead and dump that in there. You want to keep this as extra as a backup so that if the first time it doesn't go well or running a second trial to make sure you get the same number of drops, you're going to then take your tube, pour it into your sample here. And then now you're on to the home stretch here, where you're going to take your sodium thiosulfate solution, and you might want to just make sure the stopper's on. Give it a little shake. It's been sitting there for a while. Make sure all that chemical is there. And you're going to titrate, this is kind of what that's called, counting the number of drops, straight up and down as best you can. And you can shake after each one. And you want to continue until it goes from yellow to colorless. So I'll do that a little bit closer here. And if you can see, so I think that was 3, 4, 5, and like I say, give it a little shake. 6, 7, 8, 9, 10. And I would say you want to ask your lab partner, but I'm at 10 and it looks pretty clear. So now what I want you to do is think about, what does that mean, 10? 10 what? So at this point, maybe pause it, figure it out from your directions or from what we've talked about. What do your results mean? 10 what? All right, hopefully Mr. Mott and Mr. Scott talked to you in terms of what does that mean? That's parts per million. And we had a visual with the all in class, so you can remember back to that visual aid we showed you what a part per million looks like. Anyway, your results are 10 parts per million. You might want to compare that to other class data and then travel on to another site. Okay. Okay, that's Mr. Scott giving you an update on how to run dissolved oxygen.